Hello there, and thank you for listening to our presentation with regards to our final thoughts on the Model-Based Systems Engineering, or MBSE, Modules 1, 2A, and 5, which we covered as a part of our CGT 313 class. I am Rohan, and along with Emily, we are Group 6. After completing these modules, Emily and I were both left with many takeaways and lessons, which we plan to bring with us into the future. As we thought about these more, we worked to consolidate these different thoughts into one main concept for each of the modules. In Module 1, our biggest takeaway was the approach of systems thinking. Systems thinking helps in all phases of product development. This can be used in the planning, manufacturing, and even the use stages of a product's life cycle. Systems thinking is looking at the product and the parts surrounding it. As important as it is for the product to work, it is even more important that the product works in the context of its larger system as a whole. For Module 2A, our biggest takeaway was that the elements of user interaction within MBSE. The MBSE course does a really good job of explaining that a system may be foolproof, but it is still only as good as the people who are using it. Because of this, it is important for any MBSE approaches to be foolproof and easy, not only from a software and code standpoint, but also easy enough for the users to understand and be able to interact with them efficiently. Finally, in Module 5, our biggest takeaway was the need for corporate interaction and management to effectively implement MBSE. While theoretically, a company could adopt MBSE approaches from a bottom-up approach, it is not likely for this to be effective. A company can transition into MBSE approaches much faster when the managers are on board too. Hence, the managers would be able to help others adapt to model-based systems engineering. So how will these takeaways relate to virtual product integration, product lifecycle management, and the digital enterprise? First, looking at systems thinking, this plays into VPI due to the need for a product to be able to work within the system as a whole. In PLM, this plays into product management, such as performing maintenance on a system, like changing a tire on a car. And finally, in digital enterprise, systems thinking affects how companies ensure that they can manufacture and assemble a part within their existing manufacturing facilities. Looking at user interaction, in VPI, this means designing a product or solution with the end user in mind. In PLM, this also goes into repair and maintenance, such as performing an oil change on a car. And finally, looking at the digital enterprise, products and systems can be displayed in different ways. Further, the digital enterprise allows for parts and issues with said parts to be tracked, managed, and monitored for any future needs or issues that may arise. Lastly, looking at corporate interaction, this comes into play in VPI through the use of specific design standards, such as the ASME standards. PLM also benefits from corporate interaction through the need to maintain and manage product data throughout the product lifecycle. The managers can ensure that data on a product is kept accurate and up to date. And finally, in the digital enterprise, the corporate management must ensure that all of the teams or products or systems for a given task are compatible and will not interfere with each other as production goes on, nor will they run into issues down the line because of different teams, products, or systems being used.
Now we will talk about the benefits of model-based systems engineering. Firstly, it is said that it will become an industry standard. Multiple major companies and corporations in the industry are starting to prioritize MBSE for its ability to develop, analyze, and test complex systems. Industries need it because it provides a means to coordinate system design activity, satisfies stakeholder requirements, and provides a significant return on investments. Enterprise systems are also used daily even as students in forms such as Google Drive, Microsoft Teams, Excel, Brightspace, etc. They provide us with highly proficient communication and collaborative methods. Without these forms of communication and collaboration, we would have to resort to using physical interaction to communicate and transfer information, which takes up time and resources that could be spent developing and proceeding with the project or assignment. With the knowledge that we have gained from these modules, we plan to implement these learnings in our future lives. The most imminent one could be in senior design. Most STEM majors are required to find a solution or create a product to an issue during their senior year. With our knowledge in MBSE, we can focus on how to make the processes of communication, development, and manufacturing more smooth. To do this, we should ask the question, what design aspects or systems should you be focusing on in order to make a successful project? The second scenario is in our careers. We will have to take on various projects throughout our careers, and having knowledge of MBSE will enable us to see and understand the entire process of a product, or more commonly called the product's life cycle. A good question to ask when entering the industry is how can we enable ourselves to develop or aid the company with projects through the knowledge that we have gained. Lastly, as the industry grows, so will the complexity of the system. MBSE will be implemented in companies more regularly and will be a quality that many companies will look for in an employee. Unlike most courses, MBSE has taught us to look from a leading perspective, exercise methodologies that will enable us to minimize and save resources, and better understanding of the needs of stakeholders and on each step of a product's life cycle. Thank you, and if you have any questions, please leave it on the comments below.